Hello friends, in this session we will see what are the different types of compensators. We will apply them to a system and then try to check the magnitude and the phase response of the same. Also at the same time we will try to talk about their advantages as well as their disadvantages. Let us begin. So now speaking about compensators. What are they exactly? We will try to understand them. Before that, what will I do is I will take a system, I will take an unstable system and then try to analyze something out of it. Okay, let us see that. Yes. So let me have a system, let us say GH, and this is the magnitude plot and this is the phase plot of the same. Okay, yes. Now if you observe this particular line, this is a 0 dB line. Okay, this is a 0 dB line, right? Now if you see at this frequency what has happened, your 0 dB, which means has been crossed, which means this is nothing but omega gc, called as gain crossover frequency. At this frequency, what do you get? At this gain crossover frequency, you basically get pm, right? Now if you remember that such pm, when you have pm on the, what do you say, below minus 180 degrees, then we say that it is going to be negative. Now if you think of omega pc, if you see here at this particular frequency, my phase has crossed minus 180 degrees, which means it is going to be omega pc. Now if I try to project that up, then this becomes my gain margin. This becomes my gain margin from 0 dB to this much. Now again if you see the same gain margin, if you are aware of, I told you that if your dB, if the dB is in positive, because this is definitely, this value has to be positive, which means gain margin is going to be negative. I have already taught you that, right? Now if you see here, this is the way it is, right? Yes. What do you mean by that? Whenever gm and pm both are negative, gm pm are negative, then in that case, what do you mean? System is going to be unstable, right? Now what will a compensator do? Let us just don't try to analyze that particular compensator. Let us say that, let me do a magic trick on this particular system. Magic trick if I do, and in that trick, by some means, if I am able to shift this omega pc beyond my omega gc, if I have this omega pc near here, let us say, which means if by some means, if by some means I am able to shift this omega pc from this old one to this new way, right? Which means if by some means, if by some means I can make my plot like this, let us say, goes here like this, new plot red, and at the same time, yes, definitely my omega pc which is there, this omega gc will also shift. Let us say my plot, gain plot also change somehow like this. Okay, let me just say that. Now what do you observe? This is going to be your new gain crossover frequency. Yes, this is going to be your new omega gc, right? So for this new omega gc, if you see, for this one, if you take it down here, you get this new pm, and if you observe, this new pm is positive. Similarly, at this omega pc, if you see what has happened, you will get this gain margin, you will get this gain margin gm, which is also positive. What has happened? Because of this magic trick, because of this magic trick, when I shifted my omega PC from this position to this position, what happened? What happened? My system, which was already unstable, now became stable. Now became stable, right? So if you just check out for your now, what has happened? Omega PC is greater than omega GC. If you see, omega PC is here and omega GC is here, which means omega PC is definitely more and omega GC is less, which means omega PC is greater than omega GC, which means system is stable. We have seen that, right? So moral of the story is what? Moral of the story is what? Compensator means I have to add some phase or remove some phase from the system, because if you check out now here, what has been done? What has been done? You have basically you have basically added some extra phase here, right? You have basically added some extra phase here. This phase was not there initially. You have added some extra phase, which means you have compensated for the missing phase, adding some new phase, or we can say that you are basically compensating for the missing phase. Hence, they are called as compensator. Means, if for example your phase is more than the requirement, then definitely you need to remove the phase. If your phase is less, which means definitely it has to be added up in order to bring up the stability. So this is the simple concept of compensators which we have seen. Now we will try to understand the different types of compensators. Let us see those. Yes. So the first type is the lead compensator. Lead compensator. Why it is called lead compensator? We will understand it. Before that, let me write down the transfer function of this particular compensator. The transfer function given is G lead of S, which is given by K times S plus 1 by tau upon S plus 1 by alpha tau. Okay. Whereas this K is any gain constant, any constant gain. Okay. No problem. Now, now, see dear. When I say that in my life I am leading, because now if you see you have got one pole and definitely you have got one zero, right? So if I try to find the pole zero plot for the same in S plane, what happens? This becomes the S plane. This is my S plane, sigma, and this is j omega, right? Now, what I'm saying is, please see, when I say that my life is leading, when I say stability, see, when I say that my life is leading, I say my life is leading when I see money in front of me, or when I see financial stability in front of me, when I see stability in front of me, which means if let us say I am standing here at the origin, the first thing I should see is a pole or a zero. I want to see the stability first, which means I need to find the zero first, because zero brings stability. Pole, we have already seen pole brings instability to the system, right? Which means I have to see zero first, and then definitely I have to keep the pole. Now, from that, if you understand, if you see, because of this arrangement, which means what has happened here, this pole, where is this pole? This pole is nothing but 1 by alpha tau, so it becomes minus 1 by alpha tau. Similarly, how about the zero? Zero is going to be 1 by tau. Is that right? Yes. Now, if you see, what is dominant over here? Whatever is closer to the j omega axis is we call dominant. Is we call dominant. So here we have dominant zero. Here we have got dominant zero, right? Yes. Now, because of this arrangement which we have done, what can we see from this one? We can see that this can happen when alpha is less than 1. How? Let us say. Let me take alpha to be equal to 2, for example. If alpha is equal to 2, then what will happen? I will get minus 1 upon 2 tau. And I have got this minus 1 by tau already over here. Which means what? Which means what? What will happen? What will happen? This is by the way minus 1 by tau. This is minus n here. I just saw that. Sorry. Okay. Minus 1 by 2 tau. Okay. And this is minus 1 by tau. Just imagine my alpha is 2, let us say. Then it becomes minus 1 by 2 tau. Right? Which means what? Which means what? It cannot be here. It has to be towards the right. Which means whatever we have considered is right. Alpha has to be less than 1. From this arrangement we understood. For example, if alpha is let us say 0.5, then what will happen? Minus 1 by 0.5 tau, right? Which means minus 2 by tau. So you please tell me, minus 2 by tau is coming here on the number line, then definitely 1 by tau, minus 1 by tau has to come here, right? Which means alpha less than 1 is going to be correct. Now, if you see, always remember that for lead compensator or it is a lag compensator, the transfer function remains the same. Transfer function remains the same. The only thing changes is this, alpha less than 1. In case of lead, alpha less than 1. Even if you don't remember this alpha and all, it's okay. You please remember this transfer function and then do the stuff. Whatever I show, this leading means you are having financial stability. Financial stability means you want stability. Stability means in front of you, you should see 0 first. You should see 0 first. That is the reason you have got the 0 first over here and then you have got the pole. Same concept, right? Try to remember the stories because in exam stories will be remembered, not the formula. Okay? Yes. Now, if I try to find the phase, now because we have seen that since we are talking about compensators, we are actually either adding phase or we are removing some phase, right? Which means definitely angle is of most important to us. So let us try to find the angle of G lead of S, or rather angle of G lead of J omega, definitely J omega itself. So if you see, G of J omega is what? G lead of J omega. How does that become? That is going to be equal to, that is going to be equal to how much? J omega plus 1 by tau upon J omega plus 1 by alpha tau. Is that right? Yes. Now, if I'm interested in the angle, how to find angle? Angle is nothing but phi, right? It is what? Tan inverse of imaginary part mine upon real part. So for the numerator I get tan inverse of, what is imaginary part? Imaginary part is omega. What is real part? Omega upon 1 by tau. Yes. Now minus why? Because this is the denominator. Minus tan inverse of what? Tan inverse of what? Omega and 1 by alpha tau, which means it becomes omega upon 1 by alpha tau. Is that correct? Yes. By rearranging them, I get phi to be equal to tan inverse of omega tau minus tan inverse of alpha omega tau. This is a very important angle. This you have already seen this many times, right? Anyways, now what I am interested in, I want the maximum phase that this lead compensator can inject in the system. I am interested to find the maximum phase angle which this particular compensator can add to the system. Okay? Yes. So in order to do that, what will I do? I need to find something called as maxima. If you remember, in maxima, what do? We take the first derivative, or rather if I say I will derivate this, or rather differentiate this with respect to omega, right? Differentiating pi with respect to omega, equating it to 0, and then from this you will get the value of omega at which the maximum phase occurs. So the value of omega at which maximum phase occurs is nothing but given by 1 by tau into root alpha. 1 by tau into root alpha. This is frequency at which maximum phase occurs. Now Since it is a lead compensator, the phase is going to be positive. Maximum positive phase occurs. How it is there, I will show you that. Don't worry. And what about that phase? Value of that phase. That value of the phase is given by phi m, which is nothing but equal to sine inverse of 1 minus alpha upon 1 plus alpha. What is going to happen? I will tell you. See, what happens is when you do this differentiation equal to 0, you get some value of omega at which this thing occurs, at which maximum positive phase occurs. Then you put that particular value of omega here, and then you have this particular value. What is this phi m? Phi m is what? Maximum positive phase. Maximum positive phase that compensator will inject. That compensator will inject. Okay? Yes. Now, now, how it is a positive angle? In order to show that, let me draw Bode plot for the same. How to draw that plot? It is very easy. Yes. If you remember, the first step was what? First step was what? To write down the poles and zeros, right? So yes, definitely we have got this 1 by tau. Basically this diagram itself. So if you see, the first thing will come is 1 by tau, and then I will be having 1 by alpha tau, right? Ascending order. So I will have 1 by tau here, and I will have 1 by alpha tau here. Is that right? Yes. Now, how to do? Let us see. This is magnitude, so this becomes magnitude in dB, and this is definitely going to be phase in degrees. Okay, yes. Now, let me draw the Bode plot for the same. It is going to be very easy. Let us do that. Now, do you agree with me that from 0 to 1 by tau there is nothing, so the slope has to be 0 dB. See, we have done a lot Bode plot, right? So let's not waste our time discussing about the plot, right? Anyways, now what happened at 1 by tau? What happened at 1 by tau? At 1 by tau you have got a 0. You have got a 0, which means this magnitude, this becomes 20 dB per decade. Slope will become 20 dB per decade, since at 1 by tau you have got a 0. Now what happened if there is nothing else? So this will continue further, right? What happened at 1 by alpha tau? At 1 by alpha tau you have got a pole, which means this which would have gone at plus 20 dB per decade slope now will go at plus 20 dB per decade minus 20 dB per decade, which is 0 dB per decade slope. 0 dB per decade slope. This will go on and on up to infinity. Is that correct? Yes, deal done. Now, let us think about phase. That is what is important for us, right? Now, at starting from 0 to 1 by tau, is there anything? No. So let it be 0 degrees. Here it is going to be 0 degrees. Now, what happened at 1 by tau? What happened at 1 by tau? 1 by tau, you basically have a 0. So 0 in the sense this is going to get shoot up by 90 degrees. 90 degrees. Now, after that, what happened here at 1 by alpha tau? 1 by alpha tau, you had a pole, which means this should come down like this. 90 degrees come down, and this goes like this. We have seen this kind of plots, right? Now, if I draw this smoother curve will look like how? Join the midpoints. So it is like join the midpoints this way. Now, if you see this particular point, this is the maximum phase, right? So maximum phase in the sense at this phase only what happened? This frequency occurred, this frequency, at this frequency only that phases occurred, which means it is 1 by tau into root alpha. So this frequency becomes 1 by tau into root alpha. This is that frequency. Is that correct? Yes, definitely. Getting my point, right? This is so we have seen the Bode plot of a lead compensator. Now, what will I do is I will try to find its effects on a system Let us take our original unstable system which was there and then try to connect a lead compensator to it and then try to understand what exactly happens. Okay, let us see that. Yes. So dear, if you see, this is the old system which we had taken earlier as well. This is unstable system. We have seen that. Why? Because if you check out, this is omega GC, right? And this is omega PC. What has happened? Omega PC is less than omega GC, which means it is a unstable system. We all have seen that. In case if you still are interested into it, let me say that if I draw this one down here, omega GC, what I get here is this is nothing but the PM of the old system. And similarly, if I project this up, I will get this to be GM of the old system, right? GM of the old system. Is that correct? Yes. Now, dear, see what I will tell you. What if I have the compensator here? This now, what will I do? Let me just place the poles here. This 1 by tau and this 1 by tau and this 1 by alpha tau, right? So, what will I do is I will place these poles 1 by tau and 1 by alpha tau here. Let me just place them here somewhere. Let me place the compensator between these frequencies 1 by tau and 1 by alpha tau. What will happen then? 1 by tau, let me just take it up this way. This 1 by alpha tau is going to be this way. Okay. Now, what has happened? What has happened? Let us see. Let me draw the overall system, rather the compensated system, not compensator, compensated system in green. Let me just draw and then try to understand the things. Okay. Yes. Yes. If we check out magnitude in dB, what has happened from 0 to 1 by tau, it is going to be 0 dB only with some is offset. So let me have the same way here as well. So this is going to be the same way here also for the compensated system, right? Now what happened? Now what happened? From 1 by tau to 1 by alpha tau, what happened to the gain? From 1 by tau to 1 by alpha tau, what happened to the gain? It increased plus 20 dB per decade. Slope was plus 20 dB per decade, which means now if let us say this old system black, if let us say it has minus 40 dB per decade slope, example, then what will happen? Then what will happen if I add plus 20 dBs to that one? Then the slope will become the slope. If it is like this, it will become like this, right? Slope will rather decrease. Why? Slope will decrease. Why? Because I am adding plus 20 dB per decade slope, which means now the slope here is going to be somehow like this, and then it is going to follow from here to here. It is going to follow the same pattern. Correct? Yes. Now, if you think of phase, let us think of phase. What happens in phase? From 0 to 1 by tau. 0 to 1 by tau. What happened? How much was the phase? 0 degrees only. So it is going to be same 0 degrees. Correct? Or rather, yes, 0 degrees only. Okay. Now, after that, what happened? After that, what happened? Rather, not exactly 0 degrees. It is like this, right? It is increasing. So rather, it should be. Let me consider another way. It has to be somehow like this, right? Up to this 1 by tau. Then what happened? At 1 by tau, at 1 by tau means at this frequency 1 by tau. What happened is it started increasing. It increased. Started increasing, right? Here it started increasing and it started boosting up like this, which means definitely I'll have some shoot over here as well. Getting my point, right? And then after that, it is going to go this way. So after that, it is going to go this way like this, right? Yes. Now, if you check out what has happened, this is your naive omega PC, right? And this is your naive omega GC. right? Now, at this omega GC, if you take it down this way, what is the PM? This becomes your PM, and this PM is positive. Similarly, for this omega GC, if you check out, this becomes your GM, and this GM is also positive. What does this mean? What does this mean? It means that your unstable system has now become stable. Getting my point? This is the magic trick which I was talking about. Magic trick, nothing but the compensator only. How it has happened, we have seen this. A real life example, right? Now, what are few observations which this is omega PC new, by the way? All are new, these are new values, right? Yes. Now, by the way, if you think of what, yes, if you try to just observe, if you just try to observe what has happened, what has happened? Your PM was initially negative and now it has become positive, which means what has happened here? PM has increased, right? Then what has happened here at omega GC? What happened? Slope got reduced at omega GC. Slope became like this, right? Which means slope reduced at omega GC, right? Then next, what has happened next? Initial omega PC, initial omega PC was here, but now the next omega PC is going to be here, which means omega PC has increased, right? Now, last and not the least, see what has happened. If you just see what was the bandwidth for the first one. By the way, let me just recall what is the bandwidth. If you remember, bandwidth is what you take, it is a range of frequency for which up to 0.707 you can allow. So this is, let us say, bandwidth for the old system, right? But then after that, what happened? For the new system, the bandwidth got increased. This became the bandwidth for the new system, bandwidth new, right? Which means because of lead compensator, what has happened? Bandwidth has increased. Bandwidth has increased. Getting my point? Yes. Now, if you just see, apart from this, there are few things which you may not see now. Example, there are some parameters like percentage MP, then error, etc. Somehow these parameters, these time domain parameters have also altered. But yes, definitely we cannot study them now because we have seen that compensators are for frequency domain purpose, right? So whatever we analyze here will be in terms of bandwidth, gain margin, phase margin, omega GC, omega PC, stability, relative stability, etc. Right? So the time domain specifications which are there, those we will see when we see the equivalent compensator controller there. Okay, the equivalent of the compensator here, the equivalent controller to the compensator here. When we see that, you will understand that stuff. Okay, yes. Now the second type of compensator, let us see that. Yes, the second type of compensator is called as lag compensator. Lag compensator. Now, if I have discussed that already, that the transfer function for the lag and lead are all going to be same, right? So the lag compensator also will have the same transfer function. What is that? It is k times s plus 1 by tau upon s plus 1 by alpha tau. Now, again, story repeats. If you think of lag, when you say that your life is lagging, when you say that your life is lagging, when you do not see money in your pocket, which means instability, instability, which means instability in the sense poles, which means if you find pole first, then definitely it is a lag compensator. So if you see, let me draw that S plane sigma in j omega. Now if I try to show the zeros and poles, let me just stand here on the origin. What should I see first? I should see the pole. Why? Because I have told you that if you are lagging, which means you don't have money, which means your instability, instability in the sense pole, which means first thing I should see is pole. So I see the first thing as pole. Then the second thing you see is a 0. Now, if you think of pole, what is that pole? Minus 1 by alpha tau. And then what is the 0? 0 is nothing but minus 1 by tau. From this one, it is evident that alpha has to be greater than 1. Alpha has to be greater than 1. If you remember, here what happened? Alpha was less than 1 in case of lead compensator. But in case of lag compensator, what has happened? Alpha has become greater than 1. I hope you are understanding this small point. Rest, everything is the same. Definitely, the change, there has to be some changes, but the equations will remain same. Formula will remain same. Because why? Because transfer function is same. No, transfer function has not changed. Only this alpha has changed. Now alpha has been greater than 1, right? Okay. Another observation from here is that here you please tell me who is dominant. 0 is dominant or the pole is dominant. So here if you see pole is close to the j omega axis. Pole is close to the j omega axis, which means pole is dominant. Pole is dominant. Getting my point? Yes. Now let us apply the same procedure we did for the lead compensator. What do we find? We found out that the phi was equal to what? Tan inverse of omega tau minus tan inverse of alpha omega tau, right? Yes. Then we saw omega. Omega was equal to what? 1 by tau into under root alpha. We have seen that the same it remains, right? Then we saw that phi m was, how much was phi m? It was nothing but sine inverse of 1 minus alpha upon 1 plus alpha. Is that right? Same things are repeating. Now, see, here this phase which is there, this is going to be maximum negative. How it is going to be maximum negative? We will try to see that in its Bode plot. How to see that Bode plot? Let us see the Bode plot itself. So this frequency is 1 by alpha tau and this frequency is 1 by tau. Okay. Yes. Now if you see what has happened, you see that from this 0.1 to this 1 by alpha tau, there is no pole or no 0, right? Hence it is a 0 dB, correct? Yes. Now at 1 by alpha tau, what has happened? At 1 by alpha tau, what has happened? You have got a pole, which means definitely minus 20 dB per decade is going to be there. Now what happened at 1 by tau? 1 by tau, 1 by tau, you have got a 0, which means this one which would have gone this way continued, now it will become 0 dB per decade. Is that right? Yes. Now let us think of phase phi in degrees. Definitely what is happening, let us see. So what is there between 0.1 to 1 by tau? Nothing, which means it is 0 degrees. Let me call this as 0 degrees. Now after that, what has happened here at 1 by alpha tau? So I have got a pole. 1 by alpha tau, I have got a pole, which means I will have negative 90 degrees over here. This becomes minus 90 degrees. Similarly, what happened here at 1 by tau, I have got a 0, which means this one which would have continued here will now move to again back to 0 and continue this way. So this becomes 0 degrees. In order to have a smoother curve, I will have it this way. This becomes my smoother curve, right? Now if you see this angle minus 90 degrees, this is the maximum angle or maximum phase angle, and I have told you that it has to be negative, and it is negative. This is minus 90 degrees, right? This is negative. Why? Because lag compensator will remove the phase from the system. Now the what is the frequency at this maximum point? It is going to be, yes, definitely it is going to be 1 by tau into root alpha. 1 by tau into root alpha, right? Now I will apply this lag compensator to our same unstable system and then try to check what exactly happens there, and whatever happens there is very interesting. Stay tuned. See, it is the same system. This is phase. Okay. Now since it is dB, this is nothing but omega gc, and at omega gc if you see, this becomes your pm, which is definitely negative, and this is your omega pc, and at this omega pc if you find out your gm is nothing but this is your gm, right, and it is also negative. Is that correct? Yes. Now I would like to introduce my compensator from these two frequencies. I would like to introduce it from here. So let me call this frequency as 1 by alpha tau, and this frequency, and this frequency to be equal to, this was 1 by alpha tau, and this frequency to be equal to 1 by tau. Correct? Yes. I want to introduce it in between these. Okay. Green plot. Green is for compensated. Compensated, not compensator. Compensated system means basically system plus the compensator. Right? Now, what has happened from 0 to 1 by alpha tau? Magnitude is going to be 0. So the slope is going to be 0 dB. So the same thing will come here. It's some offset. Okay. Yes, it has come. Now, what happened at 1 by alpha tau? 1 by alpha tau, what happened? Slope became minus 20 dB per decade. So it will become somehow like this. It will become somehow like this. Now, after that, what happened? After that, what happened at 1 by tau? 1 by tau, it again became 0 dB. Means again it will follow the same, which is the old system. Correct? Yes. Now, what about the phase plot here? What about the phase plot? From 0 to 1 by alpha tau, 0 to 1 by alpha tau, it was 0 degrees only, which means it is going to be the same way, right? Then afterwards what happened? Afterwards what happened? It suddenly dropped down to minus 90 degrees. Suddenly dropped down to minus 90 degrees means it became this way, minus 90 degrees. Correct? Up to here. And then what happened is after some time it again became 0 degrees. So it again started following the routine. Correct? Yes. Now, if you check out what has happened now, just try to understand what has happened. This is your NIV omega GC. Yes. This is your NIV omega PC. Yes. Right. What has happened now? At this omega GC, if you see, if you just take it down this way, what happens is you have got this PM. Similarly, at this omega PC, if you check out, this becomes your gain margin, which is negative itself. What does this mean? What does this mean? This means that, see dear, this means that this initially it was unstable, yes, but now it has become even more unstable, right? Because what has happened is GM has reduced, yes, PM has reduced, yes, omega GC has reduced. Omega GC, it was initially here, it is now here, which means omega GC has also reduced. So let me just simply write them down so that it will become easy for you. It will become easy for you. So omega GC reduced, yes. Omega PC reduced, yes. Slope at omega GC, because if you see at omega GC, this was initial slope was this way only, but now it has become this way. Initial was this, but now it just became this way, which means slope has increased. So omega GC slope has increased, and definitely PM reduced and GM also reduced, which means now last parameter left is the bandwidth. If you check, original was up to this was old one, black, right? Up till black, if I say this was the bandwidth for the old, but for the new one, bandwidth has just been up to here, which means bandwidth has also reduced. What does this mean? What does this mean? If original system in black is already unstable, then the lag compensated system will become even more unstable, right? So If the system is already unstable, then we do not directly use lag compensator. So in such a cases, what we do is we first use lead in order to make that unstable system as stable, and then if we want to change any parameters, we use the lag compensator. Definitely what parameters are changing, those are the time domain parameter. We will talk about those parameters when we talk about controllers. Definitely we will talk about them, okay? But for time being we can see that. So the lag compensator are usually used for time being. I am telling you that lag compensators are usually used to reduce the steady state error, right? But I just cannot show you that here, but I will show you that in our next topic, which will be controllers for sure, right? So this was about the lag compensator. Now we will try to understand what is a lead compensator, what is lead lag compensator or a lag lead compensator, the third type and the final type. What will happen to this one? Again, the transfer function remains same. G lad lib of S. What is the transfer function? Same. K into, let me consider lag first. So 1 by tau 1 upon, let us say, S plus 1 by alpha 1 tau 1. Same equation is there. No, only in place of tau I've got tau 1 tau 2 now. That's it. So next is what? Let us say S plus 1 by tau 2 upon, what will I call is the first one, let me call it as lag, and the second one let me call it as lead. Now how will be the poles reversed? See, things will be very easy. This is very easy, right? I'm standing here, let us say this is sigma, this is j omega, right? What is going to happen? Firstly, I will consider lag. So lag in the sense I am lagging in my life. Why? Because of money problem. Why? Because instability. Why? Because instability, which means pole has to come first. Definitely I find pole first. Then I will find zero, which means what is this pole of lag? It is going to be minus 1 by alpha 1 tau 1. Similarly, the zero of the lag is going to be minus 1 by tau 1. Now, if I think of lead, what will happen? This becomes, first I will, because since it is lead means I'm happy in my life. Stability is there, stability is there, which means zero I should see first. Zero I should see first means I will definitely see this zero of this one, which is 1 by tau 2. So minus 1 by tau 2 is the zero. Similarly, what is the pole of the lead? Pole of the lead is minus 1 by alpha 2 tau 2. This is the pole of the lead. So what do you understand from this? You get that this is going to be contributing to the lead part, and these two is contributing to the lag part. Getting my point? Now for lag portion and for lead portion, what exactly happens? Let us try to understand. For lag portion, what happened? How much is omega lag? Omega lag in the sense it is the frequency at which the maximum negative phase occurs. It is the frequency at which maximum negative phase occurs, and it is equal to what? 1 by tau 1 under root of alpha 1. Correct? Yes. Similarly, what is phi m? What is that maximum negative phase that will occur? That is nothing but sine inverse of 1 minus alpha 1 upon 1 plus alpha 1. Correct? Done. Deal done. This is maximum negative phase phi m. Now, what is lead? Let us think of lead portion. Lead portion, what is going to happen? Same way. Omega lead is going to be what? 1 by tau 2 into under root of alpha 2. 1 by tau 2 into under root of alpha 2. Similarly, maximum positive phase that can occur is going to be what? Same, sine inverse of 1 minus alpha 2 upon 1 plus alpha 2. Correct? Yes, this is the maximum positive phase that can be injected. This is the maximum negative phase that can be injected, or rather maximum positive phase that can be removed. Same thing only, no? How does it matter? Now, let us draw the Bode plot for the same and try to understand what happens. So yes, what is happening? What is there between 0 to alpha 1 tau 1? Nothing is there. No poles are 0, which means slope is going to be 0 dB per decade. Now, what is there at 1 by alpha 1 tau 1? 1 by alpha 1 tau 1, you have got a pole. You have got a pole, which means definitely minus 20 dB per decade. This would have continued further. But what has happened now? What has happened now? At 1 by tau 1, what is there? 1 by tau 1, there is a 0. 1 by tau 1, there is a 0, which means definitely this becomes now 0 dB per decade. Similarly, what happens at 1 by tau 2? 1 by tau 2, what you have? 1 by tau 2, you have a 0 again, which means again this would have gone straight, but it will not go straight. It will now go this way, plus 20 dB per decade. Now, what happens at 1 by alpha 2 tau 2? Alpha 2 tau 2, what happens? What happens there? We have got a pole there, which means this one which would have gone at plus 20 dB will now go by 0 dB per decade. That's it. Now, if you think of angle plot, what happens? What happens here from 0 to 1 by alpha 1 tau 1? There is nothing, which means there is going to be 0 degrees. There is going to be 0 degrees, right? Now, after that, what happens? Let us see. At 1 by alpha 1 tau 1, I have got a pole. How do you know that? Because minus 20 dB per decade itself says, no? So, which means this will become like this, minus 90 degrees. Now, at 1 by tau 1, I have got a 0. I have a 0, which means this goes up like this and just continues this way. Then, at 1 by tau 2, what is there? 1 by tau 2, what is there? Again, you have a 0. Again, you have a 0. How do you understand that? By seeing here itself, you can see that logically, right? Because slope has increased here, which means definitely there has to be 0. So this one becomes here this way, 90 degrees. This is 0 degrees. Then after that, what has happened? At 1 by alpha 2 tau 2, again there is a pole, which means this comes down here and it goes this way. So if I take the resultant, if I take a smoother curve, it becomes somehow like this, like this. This becomes your phase plot. Whereas if you see this is plus 90 degrees, which means this becomes your omega lead, the frequency at which maximum phase will be added, and this is nothing but omega lag, the frequency at which maximum phase will be removed. This is the that particular frequency. That's it. Now, if you are so much interested into applying it to some system, it is homework for you. Then you can apply this to any other system. Try to check the way we have did here. If you see, we have did here the way we did here, or the way we did it here. If you are interested, you can do that. Otherwise, it is sufficient. It is going to be enough for you. Okay. Now, in the immediate next session, we will be talking about controllers. Okay. Thank you.